Alright, then welcome back everyone. Let's solve this question. Make AP. This is a very easy question, so let's wrap it up very quickly. I hope you have read the question once. The question is very simple. They've just given us three integers, A, B, and C. What we have to do is you have to perform one operation. That is, you have A, B, C. You have to multiply any one of them by another positive integer m, such that the sequence becomes an AP. So you know what is AP, right? So AP is like the first element is A, the second element is A plus D, the third element is A plus 2D, so on. The last element is A plus n minus 1D. Right, so this I guess you are familiar in your plus 2 you would have studied. What is AP? Basically, the difference between two consecutive elements, which we call common difference, needs to be seen. Right. So basically, we have to multiply this m to any one of them. We have to do it. Okay. We have to multiply m to any one of this such that these guys in order A, B, C are in AP. So you cannot change the order. So you have basically three elements A, B, C. You have to multiply any one of these such that this sequence becomes an AP. Okay. If it's possible, print yes. Otherwise, print no. Okay. Fine. So here's the question. Basically, we have three positive integers A, B, C, and we also need to find out whether there exists a positive integer m such that if I multiply it with any one of them, basically exactly one, right? That's why I've written exactly once and exactly one of the integers, basically. So it has to be applied exactly once and only to one of the integers. Can you make this sequence in AP? Okay, fine. So I don't know which element to multiply. What will I do? I'll try multiplying with all of them. So let's try multiplying it with A. So it will become AM, B, C. Let's try multiplying with B. It will become A, BM, C. What happens when we multiply with C? It becomes A, B, CM. Okay. So we'll get a M if this is an AP, or this is an AP, or this is an AP. Right? So basically, if you want to find a M, this should be an AP, this should be an AP, or this should be an AP. One of this, if it's an AP, then if this is an AP, then you'll multiply M with A. If this is an AP, you'll multiply M with B. If this is sequence in AP, you'll multiply M with C. Okay, fine. So if this thing, basically, if this thing needs to be in AP, what does it need to happen? Basically, this basically B minus AM should be equal to C minus B, right? If this thing has to be in AP, B minus AM needs to be equal to C minus B, right? The common difference needs to be same. So it shows that AM should be equal to 2B minus C. Therefore, M should be equal to 2B minus C divided by A. Okay, so if multiplying by A turns this sequence into AP, then M has to be equal to 2B minus C divided by A. Okay, let's see here. So in this case, BM minus A should be equals to C minus BM, right? So this should be equal, right? The difference between these two. So here what will happen? Here it will happen 2BM equals to C plus A. Therefore, M is C plus A divided by 2B. Okay, so if this has to be an AP, M has to be equal to this. Notice that M is a positive integer, so this has to be a positive integer, this has to be a positive integer. Okay, fine. Let's see this. So here this should be equal to this. So B minus A should be equals to CM minus B, right? So what will happen here now? CM is equals to 2B minus A. Therefore, M is equal to B minus A divided by C. Okay, so if multiplying by A turns this into AP, then M has to be equal to this. If multiplying by B turns into AP, then M has to be equal to this. And if multiplying by C turns the sequence into AP, then M has to be equal to this. So let's keep it very simple. If M can be equal to any one of these guys, then your answer is yes. Otherwise, it's no, right? Right? Simple. So what you need to check now is whether, basically, see, important thing is this M is a positive integer. Okay, this M is a positive integer. So if any one of this thing results a positive integer, then your job is done. Right? Any one of these results a positive integer, your job is done. Anyway, this will always result a positive integer, but these two you'll have to check, right? So what you need to check here is whether this 2B minus C is divisible by A or not, because you want a perfect positive integer, right? So there has to be this 2B minus C should be divisible by A, and the result that you get is greater than 0. Okay, so you just need to check something like this, whether 2B minus C mod A equals to 0, and if this is the case, if it's divisible by A, then this entire thing should be positive as well, right? This entire thing has to be greater than 0 as well. Fine. In this case, you need not check like this entire thing will be anyway greater than 0, but you just need to check whether C minus A is divisible by 2B. Fine, because if C plus A is divisible by 2B, then anyway C plus A plus 2B by will be positive, right? Fine. And in this case, you need to check whether 2B minus A is divisible by C, and this entire thing is greater than 0. Fine. So simple, right? I don't think there's much to discuss here. So you are supposed to multiply M with any one of these. I tried with all of them. So I just figured out three cases. If M can be this, or this, my job will be done. Right? So I'll just figure out whether M can be equal to this, or this. Okay, what are the conditions? First divisibility check, and then positive, right? Just divisibility is not enough, guys. It has to be positive as well. Okay. Yeah, there's not much to code here. So this is the code. I'll not waste your time by typing in sublime text this time. So this is simple input I've taken. The input I'm taken simply because in long, I don't know what are the constraints. Yeah, constraints were okay, but I just wanted to, I don't wanted to risk it because we're multiplying here and there, right? So fine. First things first, see, we are checking whether it is divisible by a. So basically this part, right? 2b minus c is divisible by a. Then I'm checking here 2b minus a is divisible by c. 2b minus a is divisible by c. Okay, and here c plus a is divisible by 2b. Fine. So if it is divisible, then if it is divisible and then the result is greater than 0, then make yes true. Initially yes was made false. Here also, if it is divisible, just made yes true. We don't need to check for positive case because this thing will always be positive, right? So this thing anyway, c is positive, a is positive, so c divided by 2b will always be positive. Fine. And here, if it is divisible, you also need to check whether this result is positive or not. If any one of these returns true, then you can return true. So you can return true, otherwise false. This condition can be omitted, frankly, because this is basically the condition I've written where all the elements are equal. But this you can omit, right? If all elements are equal, you're probably gonna multiply with just 1, right? So this can be like, this will be handled above only. But yeah, I've just written for safety. If all elements are equal anyway, if all elements are equal, 5, 5, 5, they're all anyway in AP, right? With common difference 0. Fine. So that's that. Yeah, so that's that to the code. I hope you got something out of the video. I'll see you in the next one.